Hi, this is the last video of this chapter. And by the way, I changed the background. Did you like it? Um, I like it better, and I hope you like it. And let me know if there's any difference. I don't know how you feel, like how it sounds, and how you feel. Anyhow, the last part of the chapter is about measures of relative standing. I'm going to cover this briefly. It's important, but we are not going as deep as we did in median and mean. So let's start with the median. The starting point is the median. The idea of the median is, roughly speaking, is this. Of course, the condition was using inequality, but simply or roughly, this is approximately right. So we are looking for a value, the median, which makes the cumulative probability equals to 50%, right? So cumulative probability equals to 50% is roughly, it's not exactly true, but roughly the definition of median. And now we may change the 50% to a different number and we may get a different measure. For example, if you consider 0%, it is the minimum. If you change 50% to 100%, it is the maximum. So minimum and maximum can be obtained by changing 50% to 0 or 100%. Or in more general, we can define p percentile in this way. So if you change 50% to a different number, then you get p percentile. So think about this. Percentiles capture non-central location of data. So the 10 percentile is the bottom 10% value, right? In the distribution, bottom 10% is 10 percentile, and 80 percentile means the top 20% value, right? It's easy to understand. When you have 100 households, and if you order the households from the poorest to the richest, then the 10th household is the 10 percentile. The 80th household is the 80 percentile, the top 20% or top bottom 10%. So it's a natural way. It's an extension of generalization of median, and we are going to call these percentiles. And in more general, they are measures of relative standing or non-central location. They capture non-central location and they capture the tails, or the very top or very tail, like very bottom. And there are some other names, special cases. 25 percentile is also called as the first quartile. Quartile means the data are divided into four, and then the 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 first cutting point is 25 percentile, and second cut is 50 percentile, and third is 75 percentile. So first quartile, second quartile, third quartile is simply 25, 50, and 75 percentile. And second quartile also equals to the median, and different names. And the reason why we are doing this is I'm going to use this. I will use these names in the next chapter. So that's why I'm telling you. And I'm not going to show you how to calculate them. Um, Also, there are subtlety in the calculation formula. So, and it's not that important. There is no important intuition behind it. So I will skip that. But it is easy to understanding the percentiles is not that difficult once you understand the median, and so I will skip that. But instead, I'm going to tell you some examples where percentiles are more useful than the average. The first example is value at risk in finance. If you are interested in finance, you must have heard about finance. So, for example, when I am interested in a financial asset, what is the probability of losing 10% or worse? If I get a return of minus 10% or worse, and if that probability is 5%, then we say 5% value at risk is 10%. So if something bad happens with some probability, then I'm going to lose something. And then what is the worst 5% case, and what is the worst p% scenario? That's an important measure in finance to measure the risk of a financial asset. So in this example, obviously, of course, we are interested in the mean. The expected return is important, but also when you care more about the risk, then value at risk is more important than, or as important as the expected return. So and this is different. This is capturing totally different aspect of the financial asset from the mean. So it's another important measure. And second example is infant growth chart. I have a boy, and suppose that when I if I tell you my son is 2 years old and 25 pounds, and can you tell if it's small or big, or is he heavy or not? It's hard to tell. Well, like very few of you, I don't remember if how heavy he was at 2 years old. So I cannot understand how what it means. It's not informative. But if I say he's at 25 percentile, then it's more informative. 25 percentile means it's below average, below the middle. So among 2-year-old boys, he's at 25 percentile means he's below the middle point, but not that middle. It's like half of the middle of the bottom half. So, it is more contextual, and it's more informative and easier to understand to general audience. Unless you have a 2-year-old boy, you cannot compare. You give no comparison when you say the first sentence. So to give the context and comparable objects, percentile it plays on delivers the information we are curious about. And the third example, 20/80 ratio for inequality. So it's a commonly used ratio, like say 20% of people have 80% of wealth, for example. I don't know if I don't know if that's true or not, but anyhow, it is an important measure in inequality in inequality studies. So it calculates the ratio between 20 percentile, which is bottom 20%, poor 20%, uh, the poor household, and 80 percentile is top 20% rich. So compare how different they are. The difference between these two households is a measure of income inequality, right? So one of the useful income inequality measure, and very intuitive to understand, and clearly can compare across countries or across years. And the fourth example is standardized score. So test scores may depend on the difficulty of the test. So for example, every year I teach the same thing, but still the average score changes. I don't know, maybe some year I'm doing better than other years, or some years students are better than the others. I have no idea. Difficulty could be another reason. So then instead, so it does not show you, if I tell you the average last year class was 70 out of 100, then you don't know how what it means. But like I can say, there was a student who was within top 1%. Then it tells you that that person, that student was very good. Right, type 1% student implies something by itself. Instead, like if I said there was a student who got 70 points out of 100 points, means nothing. So, but actually he could be a very good student if like, and that's delivered. The meaning is delivered when I say he is 1 percentile. He was 99 percentile, which means top 1%. So, as I like in these examples, percentiles deliver important information, and often you are interested more on non-central location than the center. So of course, center is important by itself, and most important thing is the mean. Like needless to say, that's it. But still, there are more other important and interesting measures you need to understand. That's uh, that's the point of this last part. And thank you for listening. I'm going to continue. The next chapter is very closely related to these guys, the relative standing. I mean the percentiles. So, okay. See you in the next chapter.